Superstructure. What is superstructure? It's simple. It's the main part of the build. It's the main structure. So we're just going to have a little look. So superstructure, we have to think first of all, what does the superstructure sit on? We have our base. We've done our sub base. Now we have to think about what we're going to bring above that. So we need to look at thermal breaks because we do not want thermal bridges. So we look at ways of compensating for this. This is a traditional base. So we're just going to have a look at things we can look at. So we have here, we have a 65mm thermal block. Basically, that's a foam glass. So it's designed to be a thermal break for block or brickwork. So this would be sitting on here, creating a thermal break here. This is an insulation which is underneath the screed. And we now have cancelled out or compensated for that thermal bridge. Here, we were, obviously this one's been unable to cancel out thermal bridge because of the makeup or the design. It has, however, got its insulation to the external block work, which will be in the cavity, but it's got additional insulation here, which is carrying the concrete floor or concrete or screed floor. So you have an insulation where the insulation rises with an additional membrane. That means that we've compensated for the cold bridge there at that point. At least that is the best that's been able to be done with that situation. Sometimes we have to have compromises, but we must always do something. So once we have our sub base done, our sub base is this area here, which is an insulated slab. It's an insulated base. That means that then we can bring up our block work and brickwork off that same base. Just because we've changed how we've done our base doesn't mean to say we have to change our superstructure. Doesn't mean to say we have to change the way that we construct on top of that. So when it comes to superstructure, many different types. Also, when it comes to the sub base or the base, doesn't mean to say we can't build different processes on it. Here we have a twin wall stud system with an insulation. This is to a passive house standard. And this is again thought about, designed about getting rid of thermal bridge. The whole thing is compensated for by design. Different types of stud walls, different types of structure, different types of superstructure. We have a number of different types. Traditionally, it's brick and block. We're coming away from that. We want to look at zero carbon. We want to look at energy efficiency. So what do? We go away from what is called the traditional product. And we go back to what I call the traditional product, which is timber. Timber's been used for many thousands of years and will continue to be, and is still the best and most sustainable way to construct. So what we've got is we've got a number of different versions of a wall. Here we have a closed panel system, which is basically I-beam with insulation between and a racking board either side. What is a racking board? A racking board is a timber or a board which is nailed onto the outside and inside of a stud work. Could be a twin stud work, it could be an I-beam. In which case what that does is it's trying to prevent that movement of wind and movement. So that is the racking strength, and that's what these boards provide. Various different sorts of insulation. Again, stud work, insulation between, stud work, insulation outside. Split insulation. This is becoming more popular with construction at the moment, and that is a timber stud-work inside, insulation in between, and then a structural racking board, and then an insulation on the outside with a counterbatten. So what's happening is we're insulated in between, and then any potential cold bridge here or thermal bridge there is got an insulation on the outside that acts as a thermal break. So therefore it's compensated here, it's compensated there. This one not so much, but how they've done away with it is they've gone wider. The wider you go, the harder it is for energy to transfer. So these are just a few different types of structure to which you could potentially use when it comes to superstructure. Joists. Joists is an area where potentially you're always going to get some form of an issue when it comes to thermability. So what we've got here is we've got a posi joist, which is a steel frame with timber top and bottom. And here we have a posi joist, which is actually an I-beam. So therefore, posi joist is just a term for a non-standard piece of timber on a joist. That's all it is. Many different types. I call this an easy joist, and I call that an I-beam. So what we've got is we have a decking here. This metal web comes through and it acts as a brake, and here, but it's acting as a brake for the insulation that it's a potential thermal bridge. So we need to have a look at those. These themselves are superstructure, needs to be approached all the time. We have this twin wall system here, this twin wall system here. So what we've done is got insulation all the way through here, all the way insulation through here. So this has acted as a brake for the insulation, where this should have stopped sooner and the insulation run all the way through. But this is prevalent on flats and apartments. This is where we need to look at compensation or compensating for thermal bridge. Because if you have a flat, this would be a board, a fireboard, same as this would be a fireboard. And that's to stop any penetration of fire coming up through the void, which is full of insulation. So they'd insulate on the top and run to the wall to compensate for that. Easy joists, posi joists. There are advantages to this. The trouble is with timber and some I-joists is you're so restricted to where you can drill, where you can take duct in. Now we have to remember that once we're building our superstructure, we actually have to include in that a MVHR system, a mechanical ventilation heat recovery system, and that requires ducting. That ducting can be up to 125, 150, 175 mil ducting, depending on the flow you need throughout that build. So these are the advantages of a posi joist or an easy joist, is you can run pipes and cables anywhere you like within that and not interfere with the structural integrity of the joist. Lightweight, easy to handle, precision made, and they don't shrink because there's very little timber. When you get a timber joist of 250 mil deep, over a period of time, that's going to shrink. These don't. These shrink very little. And also with the I-beams as well, very little shrinkage and movement. Insulation. Everything about a passive house and the structure and superstructure is about insulation. Here's a little demonstration of a non-standard construction roof wall connection. So basically what it is we have an I-beam system, This could be posi joist, it could be a twin wall stud system. They're all very similar and work very similar ways. But we need to continue an insulation, which is exactly what we get here. So if this is the board, this would be the insulation. We would potentially have some connection point there, but this could be dealt with an insulation in between, because you've got this be a solid mass of insulation that comes into here. the same as what's shown in there. But this is separate. So therefore, every gap in between will be continuous insulation. It's only the connection points, which is a potential thermal bridge. But structurally, you have to have these points, because otherwise you're not going to be able to retain and hold that. So this system, or this idea, works with any timber framing system. Now, that leads to something which is thermal mass. Thermal mass is what we use to control the inside of the thermal envelope. So if we have this envelope, which is airtight and got lots of insulation in, we want to control it. So what we do is we put things in to use thermal mass. Thermal mass is something that absorbs energy, absorbs heat, and holds onto it. And once it's held onto it, it'll keep it until the environment around it will drop, the temperature will drop, and then it will start releasing it to try and help keep that to a consistent standard. Anything can be used within reason of for thermal mass. Most thermal masses actually are natural products like clay. Concrete's the thermal mass. When you've done an insulated base, all that concrete on that screen, that is a thermal mass. So we can use that to control that environment by storing the energy. There's a little demonstration here of a water tube. These tubes of coloured water are thermal mass. They're absorbing energy. Warm water will hold that energy as long as the environment around it stays consistent. As soon as that consistency drops, it will release that energy. So, superstructure.